So this is the first lesson of the second unit in kinematics. We're breaking up the first unit into two parts because it is fairly large. So what we were going to do is concentrate just on the graphing tools. But here are the main ideas for the first lesson. Main idea number one, the equation for the average speed is your total distance divided by your total time. The slope of a position time graph for a moving object gives the velocity of that object. Acceleration describes how quickly an object's velocity over time changes. The equation for acceleration is your change in your speed divided by your change in time. The slope of a velocity time graph gives an object's acceleration. Okay, so let's just pick up a color here and see what we can do. So let's pick up red and start with the first example. If I have a velocity time graph, which I have in the first case, let's just put an arrow over that to say that's velocity. The change in my velocity divided by my change in time will give me my acceleration. So over here is my change in my time. Over here is my change in my velocity. The slope of that is going to be equal to my acceleration. Let's just change the colors here for a second. The area underneath an acceleration time graph, so here's the area of the acceleration time graph, that is going to be equal to the change in my velocity. I'm going to emphasize change. It doesn't equal the velocity, it equals the change in the velocity. So that's the first type of graphing you need to remember. The second type of graphing, if we have a velocity time graph and a position time graph with constant acceleration, you should get graphs that look like the following. The area underneath the velocity time graph is going to equal my change in my position or my displacement. Okay, again, emphasis change. It doesn't give me my position. It just tells me how much my position has changed. What we have with a position time graph under acceleration is a constantly changing rate at which my position is changing. So you have to take tangents. So you'd have to take a tangent at a spot. And remember, to take a tangent, you take an equal point above and below the spot you're interested in. The slope, again, gives you my velocity. So velocity is equal to change in position divided by my change in time. Now, you had a couple of questions given on the first worksheet. Number one, it said, determine the average velocity of the object from t equals 0 to t equals 0.8 seconds. Well, that is the same as drawing a line from here to here. Okay. So you can just draw a line from here to here. Your average velocity would be equal to the slope of that line. So you take the slope of that line, remember velocity equals my change in my position divided by my change in time. In this case, that's going to equal 20 meters east. And remember, this is a vector. You must put in that direction. The change in time is 0.8 seconds. And that gives me an average velocity of 25 meters per second east. Now the second part is asking for the instantaneous velocity. Well, at the instantaneous velocity, you're going to have to look at its the speed at any particular one point. You cannot just throw it into a simple equation. Here you'd have to take a tangent, and remember, with a tangent, you take your point 4, there's your point 4, and take an equidistance above and below. Now we could take 0.6 and 0.2, but you notice it doesn't give you the best tangent, so you'll start working yourself in to get a nice tangent. And what you'll get is a line that is not as steep as our original line. Because if you can see, if you look at the curve, it is very much beginning to flatten out. So when you draw a tangent to this line, it's not going to be as steep. Rulers definitely help. So if you look at the slope here, you've got a slope that is much less, and you probably will get something around 19 meters per second. So if on your homework you did that, you got something around 19 meters per second, you're on the right track. Go down to the next question. This is an acceleration question. Acceleration question is looking at your change in your velocity divided by your change in time. So what you have to do, again, is find the slope of the graph. So you start at your top point, you start at your bottom point, and you find your slope of your graph. And you go to here. Yeah, looks better. So what we have is a change in time on the bottom, a change of velocity on the side. Your total change in velocity is from 8 to 2. So that is negative 8 meters per second north. So we went from 10 to 2, so 2 divided by 10 is equal to negative 8. My total time is 0.6 seconds. And that gives me an acceleration of negative 1.3 meters per second squared north. And remember that north is the same, or let me rephrase that, negative north is the same as south. So you could write that as 1.3 meters per second squared south, because south is negative north. The second part of the question asks for the instantaneous acceleration at 5 seconds. So you look at 5 seconds. See if we can change colors here. So we look at 5 seconds. 5 seconds is about there. If you pick up a point above and below 5 seconds, you'll notice that it is much steeper. Okay. So let's get this out of here. Here we are. So we're going to get a line that is much steeper than what we started with our original line. So I can just grab this point here and oops, draw it from here to here. Get rid of this bar here for a bit. The tangent line is much steeper, and it is on the rate of about twice as steep as our original. So if you do this at home and on your homework and you get a slope of about -3 meters per second north, you're about on the right track. Okay? We'll take any questions up you have in class. I would expect this one to be done by the time we see each other on Monday. Okay? Thank you.